Hi there, YouTube and makers, and thank you so much for joining me on my channel today. I really appreciate that you've decided to share your time with me and watch one of my videos. On today's installment, I'll be cutting the two final flats on Kozo Hiroka's Pennsylvania E3 switcher steam locomotive engine tender-wheeled journal boxes. In Kozo Hiroka's book, he originally depicted using a jig in order to set the angles. In the intervening time, from when I posted my videos on acquiring those sign bars, my totally awesome wife gave me a Sherline tilting angle table. Since I have a tilting angle table, I'm going to go ahead and use that and give it a test out, and I'll be sure to show you what I think of it and how I apply it to this portion of the build. So be sure to stay to the end of the video, as I'll be having another Journeyman tip of the day, as well as give you some of my thoughts and lessons learned on the Sherline tilting angle table. So come on over here and join me at the bench, and let's make some chips. So the first thing we get is going to be the directions on top of the box. And as you can see, this is for the tilting angle table, part number 3750. So, inside the box roughly comes this. Now I already had opened it up when I got it as a gift. So on top here we've got a set of T-nuts and bolts. So a set of 4. Sherlines, as usual, rust prohibited paper. We have the tilting angle table, and of course here in the middle we've got the chuck adapter. It's got the chuck adapter and a bolt to hold it together. No markings, pretty decent. Hopefully you could see some of the machining marks on there. Looks like they used a fly cutter, I would guess. No markings on this reverse one, which would have been nice to have. And then here are laser engraved markings on this. And as you can see, here is a pointer, and it is in single degree increments. So really not going to get able to split. Might be able to split half a degree, not really going to be able to get to anything finer than half a degree increments on this. And of course this is adjustable. Now one thing is, these clamps are for my mill vise here. Sherline shows a few different configurations for, oh, let me turn that upside down. But Sherline shows a few different configurations for a chuck, as well as the mill vise. And as you can see, there are 4 clamps. This set does not come with any. So when using this sign plate here, I'm going to have to buy an additional set of these hold downs. So that's PN 3058 to get 4 in total in order to clamp that vise. First things first, I'm going to go ahead and remove the chuck adapter as well as its retaining. And as you can see in this quick shot here, it's a nice view of all the different hole patterns available. I'm going to go ahead and zero out my pointer. It's comprised of 3 parts: a bolt or screw, a pointer, and a locking nut. These parts allow for some pretty fine adjustment, and I can really get that pointer to be the center of the mark on the scale. I imagine together they should provide accuracy to within a degree. Looks much better. Yeah, I can work with that. So these ones here, as you can see, are in. These ones on the end, hopefully you can see that in there, are slightly off. It actually isn't an issue with the tooling plate. very specifically in the directions, now that I've seen this and read it again, I realized that the sign plate really does need to be mounted to the table. And that's purposeful because in these directions, they specifically note and talk about how we're going to be stacking tolerances. So I'm going to be stacking tolerances of the cross slide. I'm going to be stacking tolerances on the tooling plate. I'm going to be stacking tolerances of the angle plate base. I'm going to be stacking tolerances of the angle plate connector here, lever here. I'm going to be stacking tolerances on the vise. I'm going to be stacking tolerances on the parallels and stacking tolerances on the part to be machined. So removing this tooling plate is going to remove one more stack tolerance. And I'm okay with that. And looking at the angle plate, it is specifically designed to go in these slots. These nice and loose. And you can see there's a good deal of movement, probably, I don't know, 20 thou or so. So I don't necessarily want to crank these down all the way, but just enough just to snug. So I'm going to use this little bit of play to my advantage to get this nice and trammed in, and treat it kind of like one of these is too tight. Treat it sort of like the tooling plate. There. So snug but not tight, not even snug. So I'm going to be able to use, there, I like that better. For our edification, I'm going with this setup here. So you can see that the clamps are going to be a bit staggered. Mounting the vise is pretty straightforward. Unfortunately, with the tilting angle table, there are no alignment pinhole, so I can't pull those from my tooling plate and use them here. I am personally, for this first go around, because of the amount of play on the sides as well as in between the individual components, I'm going to tram in everything to the vise. I'm going to do so with it flat or the 0 position. And here it's going to be not too dissimilar than tapping it into position as with the tooling plate. I'm going to make sure my screws are tight but loose enough to give a little bit so that I can just very lightly wrap on the corners in order to get my vise trammed in. It brings it into tram fairly quickly doing this method, after having done it numerous times when dealing with the tooling plate. If things aren't exactly as tight as I want, whether they be too tight or too loose, I can always go back in and loosen them up. Now let's take an up close look at what this fine tuning looks like. As you can see, I've got a bit of a nick on there. While the nick does get picked up by the dial indicator, I don't anticipating it interfering with the vise. Fortunately, I didn't do it by machining. It was more of an accident by dropping, but it's still there and it's going to need to be dressed to ensure that it doesn't impact my machining operation. Fine tuning is pretty straightforward with a few light wraps on opposing corners. It quickly brings everything right into tram, and I'm running well under a thou and splitting into the 1 or 2 10 thou range with this. I'm going to go ahead and tighten all my bolts in a cross pattern, similar to the way you would do with a car tire. I'm only snugging the bolts a little at a time, furthest ones apart from one another, in a star or cross pattern. And I'm keeping an eye on my dial indicator to ensure nothing was over torqued, none of them were over torqued, and effectively either twisting the vise or twisting the tilting angle table. And as you can see, the dial indicator gives me a clear indication that nothing has shifted. Now I'm going to be tramming in the y-axis of the vise. I chose to do so. The sides of the tilting angle table on the sample I received were a bit loose, and they were loose out of the box, and they showed they had quite a bit of play. So I felt that to get a higher degree of accuracy, I would tram in on the hard jaw in this area of the vise. In hindsight, I would have probably approached this differently, and I'll get into that a little bit later in the video. But as you can see here, I'm going to be loosening the bolts and then kind of camming down or camming up opposite corners to get the vise to tram in. And you know, it worked. It held well together, and all the blocks that came off appeared to be very consistent Actually, they were all consistent. And especially on this 45-degree cut, all the sides that were removed were spot on accurate. And when I hold it up to a machinist square, they showed that equal amounts of material were moved off of either side. I had found that even though a little bit of torque or tension had been put unevenly on the sides, that it still maintained its hold and position. Now the first thing I want you to see here and listen to is the sound of the cutter going all the way across. Very uniform and the same. Because if anything had been canted on this first light cut, it would have told me by either coming off of it, because I'm only taking a little less than 5,000. I just got it to touch off and go. And with any kind of cant, it would have lifted up and off the cutting piece. Then as I make the entire length, I'm looking at the width of the cut. And I can see from start to end, it is uniform. And with that, I feel confident that I have eliminated any kind of cant on this first 45-degree cut. In the beginning here, I'm taking like only a couple 15,000 cuts, but by the end, and certainly by the 8th block, at least for the first 1.5 rotations, I was taking 15,000 cuts. And I found that the machine could handle it adequately, and same with the 7. I was a little skeptical, but I'm happy to report that it did have the rigidity required to do so. And that became a huge relief, being able to take those 15,000s versus 10,000 cuts over and over again. And I'm being a little bit more precautious, generous with my cutting fluid, because for me, fortunately, cutting fluid is inexpensive and plentiful. Good cutters that function really well are not. So I'm going to be dusting it, not dusting it off, but clearing the chips and applying fairly regular interval fluid every time I go back and forth. And I'm especially doing it on this first bit because it's the 15,000 cuts. I want to make sure that nothing slips and nothing ends up crashing. I'm going to keep repeating this until I basically take it all the way down to my layout lines and then check them against the square. Something has to be said here for filing, because I have to deburr in order to get it loaded up and prepared for my second cut. But also, this is a very aesthetic portion of it. And poor filing practice here is going to round off the edges, knock off corners, and it's going to take all this hard work I've done and just make it look rounded off and sloppy. So when I file, I'm going to make sure that my file is clean and my workpiece is clean of any cutting fluid. I'm not going to apply very much pressure, barely applying any more pressure than the weight of the file. I'm just letting it right across and cut at its own rate. And I'm only doing a few strokes and then feeling it. And then turning it the other way, doing a few strokes and feeling it, because I removed the burr on one side, but then I fold it over the other. So I'm going to flip it around and hit the other side to knock off that burr. And again, just keeping an angle really close to the plane of the machine surface, because I want these sides to be really sharp and crisp, because it's an aesthetic thing, and any weird rounding is going to really stand out. Yes, there were rounded corners in the real thing, but here, those rounded edges, I don't know how well I can hide them with paint, but they really do stick out. And unfortunately, I've got a few samples that I was a little sloppy. Now, I'm not as worried as this other angle, because I'm going to be coming in and machining up to it when I do the other angle. What I found interesting was that the 45 degree was really easy to tram in, but the 16.7, and that's what I calculated from a 3:10 ratio triangle, really hard. And I had to do a lot of twisting and torquing to get it trammed in, and to the point I had to be really careful where my pointer was at, because it could easily come off of the 16.7-ish position for the degree measurement. But it did tram in, and that tram held from workpiece to workpiece throughout this project. And in fact, I was able to do it over the extent of a week, and all my tram held and my positioning held on this tilting angle table. So I do feel it is a very well made piece, because I was concerned about the twisting, and that is such a relief to be able to work at your own pace, come back to it days later, and for it still to all tram in and to have the exact same cut every single piece, from number 1 to number 8 to number 24. As you can see, even at this angle, parallel slips. And I want to make sure that everything is nice and clean and chip free. One of the problems is, how do we know all the calculations are going to line up? And how do I know that I'm not going to be running my cutter into, let's say, my vise in this setup? How do I know that I've got my journal boxes in the right position to where I can still achieve the cuts I need, but not damage my tooling or anything else? And that brings us to today's Journeyman tip of the day. And that is something called, well, I guess you could call it as taking kind of a cross cut. Or rather, I should say, without actually taking a cut, running my tooling over its intended path. A lot of CNC software will actually demonstrate tool cutter path. In fact, going back to the beginnings of CNC, well into the 70s, many machines had this function built into them. Here, I'm going to be using a ghost cut, or rather a set of practice passes, to check to make sure that 1, my tool cutter doesn't impact the vise, but 2, in order to run it along the cutting edge, I should say, run it along my layout lines to ensure that nothing is canted, as well as where the 16.7 degree flat is going to intersect the 45 degree cut. So before I cut anything, it'll show me if anything is canted and whether or not all my calculations are corrected, so I don't end up scrapping any parts or damaging tooling. Now come over here and let's see what that looks like. So first thing, of course, I'm going to bring down my cutter and line up one of the leading edge of the cutting flutes with the layout line I previously made, and using my loop to make sure it's all nice and lined up. And as I move it across the y-axis, I'm going to check to make sure that it tracks the whole time, and I'm going to check it against the edge left behind in my 45 degree cut and line up a flute there. Now I'm going to go ahead and machine the bulk of this off till I get to about the last 5 or 10 thousandths, and we'll check out what that final finished cut looks like. Once happy with the alignment, I'm checking my layout line to see about how much I got, and it looks like I've got about 5,000 to knock off on the layout line, and hopefully that'll bring in that last little bit that you can see there on the left. Generous amount of cutting fluid, and I'm going to go in with my 5,000 cut, and I'm really in love with these titanium nitride 4-flute American made end mill cutters. With a fine finish, they perform very well with this steel that I'm using, and they just track right along. Good chip removal, evacuation, and where they overline each other, they leave a just fantastic feel. But that's only possible because I've taken the time to invest it in great tram work. And as you can see, that edge where it mates up to the 45 degree just disappears perfectly, and there's just a nice, clean, crisp edge. And I'm just really happy about that. And as you see, it's uniform all the way across, so no cant, nothing to worry about. You could see something there, but it is just dead smooth. So I think that's going to paint up absolutely beautifully, and this is going to be a really great looking piece. And of course, the loop shows that I've hit my layout line. Now that went really well. I really like this Sherline tilting angle table. I think it's going to be a great tool to have in my inventory, and it's going to find some good use. Now, I would be lying if I didn't say that everything went to plan or totally perfect. I did make a mistake, and I only ended up with 7 out of 8 perfect. Though even on this one that I messed up, and that had nothing to do with the tooling, it was my mistake. For whatever reason, when I went to cut the flat, this last flat, I mounted it weird like this, when I should have mounted it like that. And I even remember thinking at the time it looked off. Well, it wasn't until I was well into my first cut that I realized I made a terrible mistake. It happens. And unfortunately in this case, needlessly so. Hopefully with this damage, I'm going to try soft soldering and maybe filing it out. If you guys have any suggestions on how to recover this bit, please let me know in the comments below. I'm quite happy with the performance of this tilting angle table. Now, after having done everything and gone back and thought about it, I would have maybe trammed it in a little different. As seen here, I probably would have started off by tramming in the top plate of the tilting angle table in the horizontal position. Then I would have trammed in the top plate in the 90-degree or vertical position. And in that spot, loosen these side plates and move them side to side, back and forth, up and down, until in the 90-degree position that was accurate. Then top plate itself in, say, like in around 15 degrees or 30 degrees, some increment like that, and check the tram and fine-tuned it. Then I would have mounted my vise in the angle I was intending to cut in, where that's the 45 degrees in the instructions or the 16.7, and trammed in the vise. And fine-tuned the top plate with, as you saw, by that tweaking and twisting, and utilizing that built-in tolerances. And in fact, when I went back and did this and checked it out, it was just spot on. But regardless, it still worked out well, and I'm very happy with the results. And I'm really impressed by these dimensions provided by Koza Hiroka. This part came out wonderful. And in fact, the only problem there is, except for a little mistake I made, that really was my fault, was really the filing, and not doing a clean filing work and keeping those nice, crisp, sharp edges. So hopefully you found that useful and maybe a little inspirational on your build. Be sure to hit that like and subscribe button, as well as the bell notification, so you never miss another installment of my build of the Koza Hiroka Pennsylvania A3 switcher steam locomotive engine in 3/4 inch scale to run on a 3.5 inch gauge track in a 040 configuration or layout. Until next time, have fun out there, stay safe, and keep making chips.